Welcome to this short video lesson on file access methods and essential storage performance concepts. In this video, we'll explore how computers access data from storage, and we'll break down key terms like seek time, rotational delay, and buffer. Let's dive in. Let's start with file access methods. In computing, when data is stored in a file, the way that data is accessed can vary depending on the file's organization and purpose. There are 4 common file access methods: sequential, direct, random, and indexed sequential access. Sequential access is the most basic method. It reads or writes data one record after another, in the exact order they are stored. This is like reading a novel. You start from the first page and move through each page until you reach your destination. If you want to find something in the middle of the file, you still have to go through everything before it. This method is simple and efficient for tasks like reading log files, processing batch transactions, or streaming audio and video. Direct access, also known as random access, allows you to jump directly to a specific location in the file without reading previous records. Think of it as opening a textbook to a specific chapter using the page number. Direct access is used when data is stored in fixed-size records and you know exactly where to look. This method is commonly used in databases, where a specific student record or customer profile can be retrieved instantly using an index or ID. While often used interchangeably, random access can imply less predictability in how data is retrieved. For example, when a music app shuffles songs, it accesses them randomly rather than in a set order. Now let's look at indexed sequential access, which is a hybrid approach. It uses an index to allow direct access to specific blocks or sections of the file, and then reads records sequentially within that section. Imagine using a dictionary. You use the index tabs to jump to words starting with the letter M, then scan the list sequentially to find the word memory. This method provides both speed and flexibility, and it's widely used in large-scale data systems like banking applications or inventory systems. Now that we've covered how data is accessed, let's shift gears and talk about storage performance. One of the key performance metrics in reading from a traditional hard disk is called seek time. This is the time it takes for the read-write head of the disk to physically move to the correct track where the data is stored. The shorter the seek time, the faster the data can be accessed. Once the head is on the right track, it still has to wait for the disk to spin the correct sector underneath it. This delay is known as rotational delay, or rotational latency. On average, this delay is about half the time it takes the disk to make one full rotation. So, if a hard disk spins at 7,200 revolutions per minute, one full rotation takes about 8.33 milliseconds. That means the average rotational delay would be around 4.17 milliseconds. When you add that to the seek time, you get the total time it takes to access the first byte of data. In contrast, modern solid-state drives, or SSDs, have no moving parts. That means they don't experience seek time or rotational delay, which is why they're much faster at reading and writing data. Now let's talk about buffers. A buffer is a temporary storage area in memory that holds data while it's being transferred between two devices or between an application and storage. The main purpose of a buffer is to compensate for speed differences. For example, your CPU might be able to process data much faster than your hard disk can deliver it. The buffer holds incoming data so the CPU isn't left waiting. Another common example is video streaming. When you stream a video online, your device uses a buffer to preload several seconds of the video. This allows the video to play smoothly even if the internet connection briefly slows down. Buffers are also used when printing documents. The computer sends the entire document to a print buffer, and the printer reads from that buffer line by line while the CPU moves on to other tasks. Now let's look at how to calculate buffer requirements. Let's say you're streaming a video that plays at a rate of 5 megabytes per second, and you want to buffer 10 seconds of video ahead of time. To find out how much memory is needed for the buffer, you simply multiply the data rate by the time. In this case, 5 megabytes per second multiplied by 10 seconds equals 50 megabytes, so your buffer would need to hold at least 50 megabytes to stream smoothly for 10 seconds without interruption. In data-intensive systems, calculating buffer requirements is crucial to maintaining performance and preventing data loss or delays. The size of the buffer should be large enough to absorb any fluctuations in data flow or processing speed. To sum up, we've discussed 4 major file access methods: sequential, direct or random, and indexed sequential. We also explained seek time and rotational delay, which affect how quickly data can be accessed from spinning disks. Finally, we looked at buffers, their function, and how to calculate the right size for efficient data transfer. Understanding these core concepts can help you design and work with file systems and storage more effectively, whether you're dealing with large databases, multimedia streaming, or simple document processing. Please like, subscribe, and share this video. Thanks for watching this video. Keep exploring and stay curious about how your computer really works behind the scenes.